In a remote region of East Africa, radar equipment scans the skies for one of the continent's most elusive pests. The pest is known as the armyworm, and every few years armyworm plagues hit the headlines. However, when you look at the creature in question, it's difficult to imagine that it could really be responsible for wreaking such havoc. The armyworm is an inconspicuous creature that grows to a maximum of 4 centimeters long. But it is said to march in armies of millions across crop and grasslands, causing damage costing hundreds of thousands of pounds. Armyworm plagues spread mysteriously. The worms seem to disappear into thin air, only to turn up in even greater numbers, hundreds of kilometers away. But the mysterious armyworms are not the only animals to break out into plague proportions. The desert locust is the best known of all. The locust had a devastating effect on Asia and Northeast Africa from pre-biblical times until the 1960s. But since these shots were taken, man has managed to bring the locust just about under control. Another African pest that reaches plague proportions, the quelea, a finch-like bird that in good years breeds so fast that flocks can block out the sun. Like most finches, quelea are seed and grain eaters, and close to harvest time the flocks may devour huge quantities of maize and wheat. Quelea are still a formidable threat to man's livelihood at times, but they're conspicuous and can be controlled if the situation gets out of hand. But when it comes to the armyworms, or mystery worms as they're sometimes known in East Africa, the position isn't nearly so clear. For a start, most of the time it's difficult enough just finding them. The armyworm is a caterpillar which feeds almost exclusively on grasses and crops like wheat and maize. This particular species lives throughout Africa, south of the Sahara, and in parts of Australia. It is the larva of a night-flying noctuid moth. The moth is also inconspicuous. This is a male, slightly lighter and smaller than the female. The moth has a long proboscis for sucking nectar from flowers, though it feeds very little during its short lifespan of only a week or two. The adult female's main function in life is to lay as many eggs as possible, usually on stems of grass. The eggs are laid in clusters of up to 400. Each egg is smaller than a pinhead. After about 3 days, and depending on the temperature, the tiny armyworms cut their way out. They are tiny, just 2 millimeters long, and the minute heads resemble black helmets. The rest of the body is nearly transparent at this stage. The caterpillars soon disperse, spinning silken threads to abseil from leaf to leaf. At this stage, they feed by chewing strips of greenery from leaves, and they do so in earnest. The caterpillars molt 5 times and reach full size at about 3 weeks. After the third molt, it becomes apparent that there are 2 types of armyworm. It's a sort of Jekyll and Hyde situation, where the caterpillar's appearance and character depend on the conditions. Character number 1 hides itself away. It's green, rather passive and solitary. Character number 2 is a gregarious, aggressive type, with yellow stripes on a velvety black background. This character is only found in large groups. A large hatch of the caterpillars is always of the second type. In the savanna grassland, the armyworms are conspicuous to birds and quickly devoured by marabou storks. European storks, escaping the northern winter, join in. To the casual observer, the sight of storks gathering to feed isn't particularly significant, and small outbreaks of armyworms often go completely unnoticed by people. Even if the armyworms escape the larger predators, then the odds are still stacked against their survival. Hundreds of thousands of worms are killed by fungal diseases. The armyworm is also threatened by certain members of the insect community. Bombolid flies attempt to attack the worms. Many insects lay their eggs on armyworms. The larvae hatch out and eat the caterpillar alive. Only the dry husks of armyworms remain after a fungus epidemic. Ants take their toll too. Other causes of death are starvation and even cannibalism. When a mass of armyworms gets going, it sometimes eats itself out of existence. The greenery runs out in the dry African summer, and then the armyworms turn on each other. If the armyworm suffers such heavy casualties, then it's difficult to imagine how a mass outbreak of plague can ever occur. The timing is extremely important. The plagues are said to ravage East Africa at the beginning of the rainy season, especially after a period of drought. Scientists are now making their investigations at this time of year. An armyworm researcher takes to the air to look for outbreaks. He's looking for patches in the landscape where the worms have eaten out the grass. The microlight aircraft is good for surveying areas that are difficult to reach by vehicle. It also has advantages over fixed-wing aircraft. It can fly more slowly and land very close to the suspected outbreak. A pinpoint landing on an infestation of armyworms. There are thousands of worms, and they're in hyperactive columns, traveling fast in the same direction. The armyworm is beginning to live up to its destructive reputation, one which in fact stretches back to the year 1520, when a priest in Ethiopia recorded that, were it not for the hordes of worms, there would have been an abundance of crops for 10 years. The march has probably continued ever since. They devour every green leaf in their path, and they make no distinction between grass and cereal crops. Needless to say, this is where the trouble starts in East Africa. The armyworm ranks second to none in the damage it can do to crops and grazing lands, now that the locust is well controlled here. To the farmer, it can be a shocking disaster. One day he has a field of maize, 48 hours later, a field of useless stalks. The reason it's all such a surprise is that newly hatched armyworm caterpillars are so minute that they don't do any visible damage to begin with. But when the worms grow and change from green to black, they eat nearly 1,000 times as much as when they first hatched. It's only then that the plague suddenly becomes apparent, and that's often much too late for action. In one day, a single infestation of worms covering 100 square kilometers can eat the same as 10,000 cattle. And of course, a multitude of armyworm plagues can be occurring at the same time. The farmer's only hope is to discover how to control this mysterious and devastating creature. When an infestation of armyworms reaches plague proportions, it has to be attacked by every possible means. An aircraft of the Desert Locust Control Organization is brought into action. The insecticide spray is environmentally safe. It's effective only for a day or two before it breaks down into harmless byproducts. In the more accessible areas, the armyworms can be sprayed from a vehicle, using the pressure from the exhaust to power the spraying equipment. The spray halts some of the members of the army in their tracks. Multitudes also die from natural causes during the same period. This section of the army was caught in heavy rain, swept in the flood, and drowned. Some people think that rain destroys the armyworms, but in some conditions, it actually helps them. For every 1,000 dead armyworms, there are many more survivors left undetected and unscathed. Now full-sized, they burrow down into the ground. If rain has softened the soil, the digging is that much easier. Many farmers have been puzzled by this disappearing trick. One day there are worms destroying every living leaf on the farm, and within a day or two, the army has vanished. Just below the surface of the soil, the caterpillars will turn into pupae. And less than 2 weeks after that, they'll fly as moths. It was to find out more about where and when the moths fly that the Armyworm Research Group set up their scientific station in the Kenya bush country. A wind balloon is released to determine wind speed and direction. When the light fades, this infrared camera system will detect what is going on in the darkness of the sky above. The infrared system is used in conjunction with very sensitive radar. If the armyworms hatch, then the moths will show up in flight, just as aircraft show up on a radar screen. At dusk, moths that have hatched the day before and remained hidden during the daylight hours, begin to fly up from the ground and settle in the thorn trees. The radar only detects objects flying above 30 meters, and it's for this reason that radar can miss a jet fighter flying very low to the ground. In the same way, it can fail to detect low-flying moths. That's where the infrared system comes in. It covers the airspace up to 30 meters. On the instruments, there are signs of low-altitude activity. A researcher goes to check out what's happening on the ground. What was once an armyworm is now a fully adult moth. Just before the moths emerge, many will secrete a droplet of liquid. If the soil is hard and dry, the liquid helps to soften the earth. One after another, thousands upon thousands of moths appear, climbing the stalks to spread their wings. All around, over a huge area, multitudes of moths are emerging. Their wings were packed close to the body in the cocoon. Now it's time to inflate them. The moths will be ready to fly in an hour or two. At about 11 p.m., the instruments begin to show a huge flight of moths. The scientists check to see exactly what's going on. Hundreds of thousands of moths that hatch during the day are now taking to the air. By tracking the moths with infrared and radar, the scientists discovered that when the moths leave the trees, they fly at heights between 20 and 300 meters. That means that they may get into the stronger winds and even into the tropical weather systems. The clouds of moths are then swept as much as several hundred kilometers in a night. They may be widely dispersed, but equally they may be concentrated together by the winds. And if so, they will mate and start yet more plagues of worms. Now the armyworm outbreaks are less of a mystery. For by measuring the wind direction and speed at different heights, the scientists can predict where the moths will be blown by the wind and where they will strike next. In the hours of darkness before dawn, there is another peak of moth activity. In 1984, some 100,000 square kilometers of Kenya were infested by armyworms. It's only recently that the scientists have begun to understand the whole system. The key issue is, of course, how to stop the armyworm's very expensive march across the whole of East Africa. By plotting the course of armyworm infestations over the years, the research project has established a pattern that may be of great help for the control of the pest. The first outbreaks were found inland from the coast. The easterly winds concentrate the moths near hills. The outbreaks move west, and if conditions are right, the populations explode. The moths then follow the prevailing winds deep into Tanzania, Malawi, Kenya, and Uganda, and in bad years, Ethiopia and even the Yemen are affected. But there are still several unanswered questions. For example, how can an outbreak be predicted? One technique involves the use of moth traps. During the night, the passing males are caught in an ingenious way. They are attracted to the trap by a plastic capsule impregnated with a chemical, a pheromone, which mimics the female moth's sexual scent. The male moths then adhere to a sticky glue on the polythene. If the moth count goes up dramatically, then the farmers in the nearby area can be warned to get their spray equipment ready. But there is one much more fundamental question. How do the first outbreaks originate? It seems to go back to the Jekyll and Hyde personality of the armyworm caterpillar. In the coastal regions of East Africa, and in places with more regular rain, there are populations of the solitary type of armyworms with a year-round supply of food. It seems that when these widely scattered worms hatch into moths, the winds may concentrate a group all together in one place. They lay their eggs, and as the caterpillars hatch in multitudes, they react to each other with a sort of mass hysteria. They become a frantic, seething mob, devouring every blade of greenery in their path. The only way to control the armyworm is to nip the developing plagues in the bud. With careful monitoring, the first few armyworm outbreaks of the season can be spotted and destroyed immediately. That should prevent the plague sweeping across the whole of East Africa. But if the armyworm has at least two sides to its character, then it may have several more. The mystery of the flying worms may only be partly solved.
A badger, a goose, some baby fox.